Welcome back. In this video, we'll discuss about shift and rotate instruction. I have already made some logic. Also, I have made logic in the ASMI. Before we go to see that logic, let's see that if you have a 1 byte, all 8 bit of that byte is high. Like if you have the main data stream that all bit is high of that 8 bit, then if you want to shift that data of the bit 8 bit, maybe one position, maybe two position, or you want to shift all of them, then how it will look like? There are two types of shift. One is left shift, another is right shift. If you think that first that right shift, then I told that it can be one position, two position, three position. First you think that two position shift right, then how it will be? Two position shift of that main data, then it will be 0 0, and then other 16 bit, other 6 bit. So the shifted position will fill by 0, and right side of that bit 2 bit, right side of 2 bit, that that 2 bit is outside of that main data stream. So it is totally out of that main data stream and it is waste. Okay, if you want to shift again two position, so what will be the shifted data? Two position shift right of that this data, then what will be shifted data stream? So first it was, second time it is shift 2, and before it was 0 0, and here will be 1 1 1. So two times again shifted, and that data from the first shifted data, that too is outside of that of shifted data stream. So total 4 bit of that main data stream is lost, original data. So shifted position is filled by 0. When you shift any data position, maybe one position, two position, or three position, that time your shifted position will be filled by 0, not the 1 or the previous value. Okay, if you shift the data in left, then it will fill 0 from the right side, and data will lost from the main data stream from the left side. Like the main data stream, if the main data stream of again 1 1 1 1 1, that is the 8 bit. If you want to shift left to position left shift, then data of that byte will be 11111 and 6, and that is 00. So from right side is shift right side filled by 2 0, and from the left side that 2 is out of that data. So this way the shift left or right is work. It can be 1, can be 2, 3 position, no issue. You have to select the position in the logic. And same way, if the data stream is, suppose for rotate, if the data stream, main data stream 101000 like this, okay, then how the rotate is work. Suppose it's a right, rotate to right, so data rotate to right side. So and 3 data rotate, if the data rotate is 3, then every time this will go, that 3 position will shift to right side, 3 position will goes to left, so and it is 0, and that 3 1 0 1, then right that 2 3 position, that 3 position already come to that 3 position, and this one just right shifted here, and in between 2 position will be here. Zero, 0. That's all. If you rotate again here 3 ROR again, then it will be that right side 3 position is this 3 position, right side 3 position will comes in left, so here it will comes 100, then other value fill in right, other value what it is 0, it is 00 0, and here 1 0, that means that 5 bit will place later. If you again shift rotate, then think that it's this 3 will comes in left side and the other bit will place here. So during the rotation no data bit will lost from the original data stream. It just shift the position, rotate the position. Okay, and same thing if you rotate left, the data will rotate in left. That means from here it will goes here. If you rotate means if you rotate that data in left, then how it will work? See here 3 ROL, 3 position ROL, and what will be look like? It is 3 position, rotate left, three position rotate left. So this one will goes to right. This way the rotate will work. So no data bit will loss. Just shift it position. Okay. Now see the program. Here already you can see the data. Okay, go to the okay. Now see the instruction. Here I have already made the logic. That first, if you go in instruction library, that here shift and rotate folder, you can see that there are 4 instructions. SHR is the shift right instruction. Here you can see there are 4 logic instruction. One is SHR, that is shift right instruction, then shift left instruction, rotate right instruction, rotate left instruction. Here I have first used the, if you call that, here just I want to show that here if you drag and drop this instruction shift right rotate instruction, then it will be look like this. This is the input, that what you want to shift the bit, position of the word or byte, anything. If your data type is byte, here it will automatically show as a byte when you call the tag here, or you can define first no issue. Here it will be the byte, word, L word, double integer, all the data types you can use here. Here n is the position of shift. You can shift the all position one times. You can shift the any number you choose the position as your program required. And here is the data will store in that tag here. When you define the tag here, the data will store after the shipment. Or you can just drag and drop the empty box here. You can write the shift R like this. If you memorize the instruction short name, okay, then it will just show like this. Okay, now here I have take a shift rotate instruction, and here I have give a also a position tag, that you can just write directly the position number that you want to shift. You can give a 1 2 3, or you can use the tag. I have used the tag because I want to give the position number from the HMI. Okay, and here the tag, that if this bit is high, that time power comes from here to here, and when the pulse, every time that pulse come here, that time it will shift the position you define here. Here 0.5 hertz means this pulse will come every 2 seconds for 2 seconds. It's system generated pulse. Okay, when the, and for here I want to see the previous tag value before the shift. That's why I have write another instruction here. That means when the value is, when the pulse is not present here, that time it will move the after value to right before value. Okay, that means that not instruction will give when the input is value 0, it will give output to high. Okay, same way here you can see already. Same way here I have load the value, because after all the position shift from left to right or right to left, the value will be 0. So all the value will be 0. If you want to see the rotation again, you have to give the load value or input value of that input. So how we can give the load value from the HMI? For that I have made the logic that when the value is 0 means the shift after shift value is 0, then it will compare to 0, and when the load bit 39.0 is high, that time it will load the value. Here I have initialized the value, load value. That value will move to shift before here. So that value again started to rotate or shift. Here I have made the logic for shift left same as the shift right here. Here I have write the rotate instruction, rotate to right, that when the bit is high and when after the clock bit is high, that time it will rotate the bit position here defined, and the rotate value will store here MB47. And here for see the before position of the rotation, I have made the logic that the when the bit is 0, that means no rotation instruction execute. That time I have load the after value to before value. Okay, now see from here you cannot see the binary here you cannot see binary rotation. You can see here that this is the shift rotate right. That time okay, see it will shift 0. Here it will shift right to left, shifting left. Here 11 after 1 here 0, again it is 1 here still 0, then that 0 will load to before. And here rotate, see that rotate value, initial value was 6 0 bit and 2 1 bit high bit, and it rotate every time one position 1 0 0 0. See here it will start again, right comes here left, so it start again. It is not lost that bit, but here you can see that it lost all the high bit 1 1 after the shift, and after the shift it all the value is 0 because it's filled by 0 after every position shift. Here if you load again, that value is like this. Here you can shift right. Okay, here because here 1 0 1 0 because it's right shift right left to right, that's why it's going to 0 again, it's load. Why? Because here the value one time it's 0, when it's 0 that time it's load to 1. Okay, here if I change the rotate instruction as rotate left, then what is changed? See here, first it was rotate left to right, now it is rotate right to left, like this way. Here you can change the position, that it will every time it will shift 2 position. See it shifted 2 position. Here if you right 4 position, every time it will shift 4 position. Okay, see here in rotate, from the HMI I have changed the rotation position, beat position, that 4. Here we can write from here also, no problem. 5, it is 5, every time it will shift 5 position. Okay, here see, you can see the 5 position. Also you can give a 6 position, it will shift, every time it will shift 6 position. Okay, thank you for watching. Okay, that's it. Thank you for watching.